Today we're going to talk about lipids. So lipids are one of the four major classes of organic compounds. Organic compounds are compounds that are living and have carbon in them. So lipids are essential for cell growth and they're found everywhere in the human body. They are produced in the small intestine. Here you can see a picture of the lipids here, where it says lipids right over there. So what are the functions of the lipids? Well, first of all, lipids store energy by the means of fat. So if ever the body needs energy, they're going to transform the fat into something the body can use and use it. Always remember that lipids are not the primary source of energy for the body. It's actually carbohydrates. So it's like probably the secondary or the third mean of energy for the body. Lipids also have heat insulation in the form of fat. Here you can see a picture saying false, the human body is buoyant. Well, the reason why the human body is buoyant is because of lipids. Lipids are less dense than water, and that's why they help to make animals' bodies buoyant. On top of that, lipids are also essential for cell growth. So we're going to learn about triglycerides, and we need to know what they are before we actually do. So triglycerides are esters of fatty acids with glycerol. So the average length range of triglycerides are between 14 and 24 carbons, and they're made with 3 fatty acids and 1 glycerol, given the fact that water is gone from the mixture. So here we have animation. So the water goes away. So as you can see, the blue ones are the fatty acids, and the red one is the glycerol. They might not look like the real things, but so as you can see, one of the fatty acids is already attached with the glycerol. So another one comes in, and so does another one, and now you have a triglyceride. So now we're going to learn about the different types of fatty acids. Well, fatty acids are actually acids that are produced when fat is broken down, and there are 2 types of fatty acids: saturated fats and unsaturated fats. So saturated fats are solid at room temperature, while unsaturated fats are actually liquid at room temperature. Saturated fats are found in animals, whilst unsaturated are found mostly in plants. And saturated fats have no double bonds between carbons, which is quite the contrary to unsaturated fats, because they actually do have double bonds between carbons. So phospholipids are lipids with phosphate. So I mean, that's kind of the simple definition, but it's actually a lipid, phosphate, and 2 fatty acid tails. So phospholipids form a micelle when they're placed in water. So micelle is a tiny ball of molecules, and it happens because if the phospholipids do not form a micelle in the water, they actually form a bilayer, but it's actually really difficult for the water to like accommodate the whole area of the bilayer. So here, let me just bring the pen on. So this is a lipid. So it's like a ball with a tail. So bilayer is essentially one of this and another one like this. So imagine if this is the water and there's many of these floating around. It's really difficult to accommodate the whole area of it. So what it does is it forms a micelle. So if we look at the water from the top, so imagine you're looking at this glass of, it doesn't look like a glass, but from the top, so imagine these lipids standing and this one upside down. They're standing and they're floating around. Instead of that, they lay down and they form a micelle. So it's much easier to actually accommodate the area of it because it's laid down, and you don't have to accommodate the whole area of all of this part. So a phospholipid bilayer is a thin polar membrane made of 2 layers of lipids. And so before I go, I'm going to make a sketchbook for this, and before I actually do it, you need to know 2 terms: hydrophilic and hydrophobic. So hydrophilic is able to dissolve in water. So things like maybe Kool-Aid and other types of drink mixes and sugar, they are hydrophilic because when you mix Kool-Aid in water, it dissolves. But hydrophobic are things that simply do not mix in water. So I mean, I can't really find I can't think of an example right now, but so we're gonna move on to the sketchbook. Today we're gonna be talking about phospholipid bilayer. So phospholipid bilayer. So here I have a picture of a lipid. So it almost looks like a guy with a head standing. So phospholipid bilayer, bi meaning 2, so a phospholipid 2 layers. So there's many phospholipids. See, it's a phospholipid.
and it's a bilayer, so there's going to be an other layer of this. So as you can see, there's two layers, 1, 2. So all the ball things, they are hydrophilic. So which, as you probably saw on the podcast, which means that they actually dissolve in water very easily. But all these strands, they are, oh, I need some more space, hydrophobic. So which means that they don't mix with water very well.
So now we're going to make another sketchbook comparing carbohydrates and lipids, because I'm pretty sure a lot of people actually get them mixed up.
So the first difference is that carbohydrates are hydrophilic, while lipids are hydrophobic. So for example, oil, so vegetable, just any oil, for example. So you know it's a lipid because when you put it in water, it's not going to mix, so it's hydrophobic. But Kool-Aid, for example, when you put it in water, it's going to dissolve and mix. So you know for sure it's hydrophilic. Another difference is that sugars are made of many subunits. So like a monosaccharide is the simplest form of sugar, and a polysaccharide is made out of many of the monosaccharides. So it's kind of going from small to big, mono, di, poly. But a lipid, on the other hand, is, well, they don't form like polylipids or anything. They just form a lipid or a phospholipid. So they don't have subunits. So another thing is that both of these things store energy, but carbohydrates, they are the primary source of energy. But they don't store as much as lipids. Lipids, they are the secondary source of energy, but they store a lot more energy as fat. But as I said, they're not the primary source of energy.
Thank you for listening.